Networks are the invisible backbone of our digital lives, powering everything from streaming and gaming to remote work and global communication. But what if your network could do more than just keep up? What if it could think, adapt, and optimize itself in real time? That's exactly what software-defined networking, or SDN, brings to the table. For decades, traditional networks have been reliable but rigid, struggling to meet the demands of our fast-evolving world. SDN flips the script, delivering flexibility, intelligence, and control like never before. In this video, we'll explore how SDN revolutionizes network management, scalability, and adaptability, and why it's becoming the future of connectivity. Because traditional networks rely on rigid hardware-based infrastructures, they struggle to adapt when demands rise or traffic patterns shift. Manual configurations, often performed on a device-by-device basis, consume precious time and increase the risk of errors. This leaves administrators scrambling to keep pace with emerging technologies. The result is a static environment that cannot evolve at the speed of modern innovation, depriving businesses and users of the responsiveness they now expect. As businesses and consumers push for services that are faster, smarter, and more dynamic, the shortcomings of traditional networking become painfully clear. Limited scalability makes it difficult to handle sudden spikes in usage. Complex, vendor-specific hardware forces organizations into expensive and time-consuming upgrades. Without a single point of control, management becomes fragmented, increasing complexity and human error. Instead of empowering organizations to innovate, these networks hinder progress, locking them into outdated methods and cumbersome workflows. These limitations set the stage for a true transformation. This is not just another incremental change. It marks the emergence of software-defined networking, a fundamentally different way of thinking about connectivity. By freeing decision-making from rigid hardware constraints, SDN promises a more adaptive, intelligent approach. Recognizing the burdens imposed by traditional models clarifies why SDN stands as the logical next step. Now let's examine the core principles of SDN and see how they turn static infrastructures into agile, software-driven environments that thrive in our constantly evolving digital landscape. Software-defined networking represents a revolutionary shift in how networks are designed, operated, and optimized. Traditional infrastructures keep the control plane and data plane fused together, forcing each device to make independent routing decisions. This approach restricts flexibility and slows innovation. SDN separates the control plane, consolidating decision-making in a centralized, software-driven controller, while leaving the data plane to forward traffic as instructed. This architecture introduces the agility needed to adapt to ever-changing demands. Northbound APIs connect the controller to higher-level applications. They translate strategic objectives into actionable policies. Southbound APIs, often using protocols like OpenFlow, push these decisions directly to network devices. OpenFlow is one of the first and most widely used SDN protocols, enabling communication between the SDN controller and switches or routers. It allows the controller to directly modify the forwarding tables of network devices, dictating how packets are routed or filtered based on defined rules. This eliminates tedious reconfigurations at each node, automating tasks that would otherwise require manual intervention. From a single interface, administrators can modify routes, prioritize traffic, or enforce security protocols. With this central vantage point, adjustments happen quickly and accurately, increasing overall efficiency. SDN's centralized controller also significantly enhances security and policy enforcement. By continuously monitoring traffic patterns, the controller can quickly identify suspicious activity, such as potential distributed denial of service attacks or unauthorized access attempts. Once detected, the controller can isolate malicious traffic and reroute it to prevent network-wide disruption or block it entirely. SDN also integrates seamlessly with intrusion detection systems, or IDS, creating a dynamic, automated response mechanism that minimizes downtime and protects sensitive data. Policies are applied uniformly across the network, ensuring that even as devices are added or removed, security remains consistent and adaptive to emerging threats. This approach not only improves resilience, but also reduces the need for manual interventions during critical incidents. Because SDN makes the network more programmable, scaling becomes straightforward. Adding capacity no longer involves upgrading hardware in multiple locations. A single software command can reroute flows or allocate new resources. Security also improves as policies apply across the entire infrastructure. Costs decline as reliance on proprietary hardware decreases. By unlocking programmability and strategic oversight, SDN reshapes rigid setups into adaptive, software-driven ecosystems that keep pace with changing requirements. This change is not theoretical. Data centers embrace SDN to handle volatile traffic volumes and ensure optimal resource allocation. 5G networks rely on it to orchestrate complex services swiftly. Integrations with technologies like network function virtualization, or NFV, IoT frameworks, and AI and ML tools deepen SDN's potential. Instead of maintaining static configurations that lag behind emerging trends, organizations gain a dynamic foundation poised for continuous improvement. An example that highlights how SDN is revolutionizing networking is Google's Jupyter Data Center network, managed by the Orion SDN controller. Jupyter supports over 1 petabit per second of bisection bandwidth, which refers to the total capacity available between two halves of the network. In simpler terms, it's the maximum bandwidth the network can handle simultaneously across its entire infrastructure, ensuring no bottlenecks occur during peak loads. This scale is something traditional networks could not achieve without significant inefficiencies. The Orion controller introduces centralized, intelligent decision-making to this vast infrastructure, enabling the network to adapt dynamically to demands in real time. For instance, during sudden traffic surges from services like YouTube or Google Cloud, Orion automatically reroutes data flows to prevent congestion and maintain performance. Its intent-based management transforms high-level goals such as prioritizing critical applications or optimizing bandwidth into precise actions across the entire network. By enabling networks like Jupyter to scale effortlessly, respond dynamically, and optimize continuously, SDN exemplifies the revolutionary shift away from static, hardware-bound architectures. This is the future of networking in action, where the network evolves as a strategic tool to meet ever-growing demands. SDN empowers networks to operate as unified, intelligent systems rather than fragmented collections of devices. Traditional infrastructures force administrators to manage each device separately, often resulting in reactive approaches that cannot keep pace with evolving demands. Centralized control through SDN allows for swift, precise adjustments that address emerging technologies, traffic surges, or security threats. This flexibility transforms the network into a strategic asset. Operators can roll out new applications or services rapidly by programming network behavior instead of physically reconfiguring hardware. Integrations with AI and ML enable predictive analysis, automated troubleshooting, and proactive performance tuning. Over time, reliance on proprietary hardware diminishes, reducing costs and increasing choice. Organizations gain agility and freedom, moving beyond static boundaries to embrace continuous improvement. However, transitioning to SDN is not without challenges. For many organizations, moving from traditional networks to SDN requires careful planning and strategic implementation. Hybrid solutions often serve as a bridge, allowing organizations to gradually integrate SDN into their existing infrastructure. In these setups, traditional devices coexist with SDN-enabled components, enabling businesses to modernize their networks without disrupting ongoing operations. Best practices for migration include conducting a thorough assessment of the current network, identifying high-impact areas where SDN can add immediate value, and starting with smaller controlled implementations before scaling across the entire organization. The strategic insights provided by SDN make the network more than a conduit. It becomes an adaptable platform for innovation. As technologies like 5G, IoT, and cloud computing continue to evolve, networks must evolve with them. SDN supplies the tools to shape connectivity around emerging needs, ensuring that the internet remains dynamic, efficient, and ready for what comes next. Integrating artificial intelligence into software-defined networking marks a significant evolution. AI-driven analytics sift through vast amounts of network data at lightning speed, detecting patterns and anomalies that would be impossible for humans to identify in real time. Instead of relying on manual interventions, the network can intelligently predict congestion, reroute traffic, and prioritize critical services. This proactive approach ensures smoother, more reliable performance, and ultimately enhances the user experience. Beyond simply reacting to current conditions, AI algorithms guide strategic decision-making. They can model future scenarios, anticipating traffic surges before they hit, or identifying hardware failures before they occur. This predictive insight allows administrators to plan resource allocation and maintenance with greater accuracy. Over time, AI-based optimization reduces costs, shrinks downtime, and eases the burden on technical teams. By automating complex decisions, AI allows human experts to focus on higher-level planning and innovation, rather than troubleshooting routine issues. As networks become more complex, AI integration enables SDN to scale gracefully. With billions of IoT devices, growing 5G deployments, and increasingly diverse workloads, the demand for real-time adaptability is stronger than ever. AI turns SDN into a self-tuning system, one that not only reacts to conditions, but learns and improves over time. This self-improvement loop promises a future where networks operate at peak efficiency, foster continuous innovation, and remain ready for whatever challenges lie ahead. As we continue to navigate the immense, ever-shifting landscape of the digital world, SDN stands at the forefront of a new networking revolution, one that reshapes connectivity into something smarter, more adaptive, and endlessly scalable. So next time you log in or connect to a new device, consider the invisible intelligence steering your experience toward greater efficiency and security. For more in-depth resources and training, including certifications like 𝗀iciSP and CCSP, head over to deskcert.com. Stay curious, stay vigilant, and until next time.